Hello everybody, welcome back. Today we're taking a look at a type of electronics problem that can be solved with complex numbers. So here we go. For this circuit, find omega, which is the angular frequency, in terms of R, L, and C if the angle of Z is 45 degrees, and find the resonant frequency omega. And we have all our equations here that'll help us out. These are all in terms of complex numbers. And we have our circuit here. So this circuit has a voltage source here that's some sort of sine wave or cosine wave, um, and that produces a current that's flowing through these three components here. So a resistor is, um, if you want to look at like the water pipe type of analogy, a resistor is a tiny water pipe that doesn't let much water through. A capacitor is like a water balloon that becomes harder to fill up the more water there is in it. And the inductor is like a water wheel that slowly gets up to speed, but it's hard to change it once it's set. Okay, so uh, this since all three of these are in parallel, they all have the same voltage across them, but as can be seen, they all have different currents going through them. Um, And one thing that we notice is that since there are no other branches, the total current going through the system must be the sum of the current going through the resistor, the capacitor, and the inductor. So, to write that out, that would be that our I equals the current through the resistor plus the current through the capacitor plus the current through the inductor. So we need to solve all these equations up here in terms of our different currents. So we can plug them into this equation. So this one, we can solve for this as V over R. For this one, the current through the inductor equals V over J omega L, which we will further rewrite as negative J V over omega L. If you have a J on the bottom of an equation or the bottom of a fraction, you can put a negative sign and swing it up to the top. And then this IC is equal to V J omega C. So plugging those all into this equation, we get that I total equals V R minus, well, we'll put a plus here. We'll factor the J's out. V omega C minus V over omega L. Don't drop any of these negatives, because otherwise the problem becomes very difficult to solve. Don't ask me how I know. We can also factor a V out of all these, which is in fact what we want to do. 1 over R plus J omega C minus 1 over omega L. So, we can get this in the form of this equation 1616 now to get what our Z is equal to. So our Z, which is the complex impedance, is equal to our V over I, total V over total I. The V is the same for all of them. The I is the total one that we just added up. So Z equals V over I, which is equal to, if we swing this over to this side of the equation, we can swing the I underneath the V. I probably should have done another step over there showing that, but this is all right. So it's this, but instead of this, it is to the negative 1, because it is inverted. Okay, so we have our z. How helpful is that? Well, it's helpful, but the fact that we have the inverse of it means that we need to keep on thinking about how this is going to work. I'm going to solve b first since it is easier. So with b, the resonant frequency, omega, is when our z is completely real. And that means that the complex part of it, or the imaginary part of it, is 0. So that means in this case, despite it being inverted, this still holds. If we get rid of the imaginary part off the bottom, there won't be any imaginary part to invert. It'll just be a real part to invert, and so it'll be a real number. So omega c minus 1 over omega L must equal 0 at the resonant frequency. We want to solve in terms of omega, so what I'm going to do is I'm going to multiply both sides by omega, which doesn't do anything to the 0 side, but it does help us out on the other side. 0 times omega is still 0. So this becomes omega squared c equals 1 over L, which further becomes omega squared equals 1 over LC, which then finally equals omega equals square root of 1 over LC. And this is the answer for part B. It's technically positive or negative, but it's not like spinning the other way around a circle really changes how this works, so that's an appropriate answer. Now for part A, which is a little more difficult. We want the angle of z to be 45 degrees. And that means that the real part is equal to the imaginary part for an angle of 45 degrees. So we have an equation that lets us divide two complex numbers. I'm not going to use z since we're already using it everywhere else. I'm going to use, what's a good variable name? Well, how about we just use y? So 1 over y, when y is a complex number, it's the same as, okay, well, if y equals r e to the I theta, then 1 over y equals 1 over r e to the negative I theta. And the part that is important to us is that the inverse of a complex number has the opposite angle. So if we want our z to have an angle of 45 degrees, then we want our inverse here to have an angle of negative 45 degrees. Which means that our 1 over r must equal negative omega c minus 1 over omega L, which equals omega 1 over omega L minus omega c. We can rewrite this, in fact, as omega, well, yeah. omega c plus 1 over r minus 1 over omega L equals 0. You might be able to see where we're going with this. We can multiply both sides by omega like we did above. 0 times omega is still 0. But this is omega squared c plus omega over r minus 1 over L equals 0. And this is a quadratic equation. So applying what we know about the quadratic formula, we can here say that omega must be equal to negative 1 over r plus or minus the square root of 1 over r squared minus 4. Actually, hold on, plus, because remember this is a minus. So if we're multiplying c over L here, that's a negative L that's there. And that turns it into a plus. Like I said, don't forget these negatives. They make the problem very difficult. And then over 2c. This is the answer. It doesn't really get any more simplified. In the way I've been testing this, it's always the positive instead of the plus or minus that is the correct of the two options there. But despite that, this is the correct answer. And thank you everybody for watching.